Hello everyone, in this video we're going to learn about rational functions and end behavior. A rational function is simply the quotient or the fraction of two polynomials. Alright, so we're going to write the rational function y equals f of x over g of x, where f of x and g of x are both polynomials. And g of x right here must be different from 0, right, in order for the rational functions to be defined. Okay, so look at the following right here. This guy, and these guys are rational functions. Alright, so for example, we have y equal to 2x squared minus 3x plus 4 square root of x over x plus 1. Alright, so this is not a rational function because the top is not a polynomial. Alright, we have 4 root of x right here. Alright, now we're going to talk about the end behavior for rational functions. So this guy is the leading term, and this guy is the leading term. So we have three different cases. The first case, if the degree of the leading terms are the same, which is n equal to d, we have a horizontal asymptote. In order to find the horizontal asymptote, we just simply check the quotient of the leading coefficient, which is a over b. Now, take a look at the example right here. Alright, question A right here. The leading terms for the numerator is 3x squared. The leading terms for the denominator is going to be 5x squared. The degree on the top is going to be 2, and the degree on the bottom is going to be 2. They both the same. So we have a horizontal asymptote. It can be y equal to the leading coefficient 3 divided by leading coefficient 5 right here. Now we're going to move on to second case. The denominator dominates the numerator, which is the degree on the bottom greater than the degree on the top. We have one horizontal asymptote, y equal to 0. Okay, so look at question B right here. The leading terms on the top should be 2x. The leading terms on the bottom should be x squared. Alright, now because the degree on the bottom greater than the degree on the top, alright, so the horizontal asymptote is y equal to 0. Alright, let's move on to case number 3. The numerator dominates the denominator, which is the degree on the top greater than the degree on the bottom. We don't have the horizontal asymptote. In this case, if the degree of the numerator is exactly 1 unit more than the degree of the denominator, then the function has a slant asymptote. So which is n equal to d plus 1. Alright, so now let's complete this example. Determine if the following rational functions have a horizontal asymptote, slant asymptote, or neither. Alright, if the function has a horizontal asymptote, write the equation of the asymptote. Alright, so question A and B we already finished. Now look at question C. Now, the leading terms right here, 2x squared, we write 2x squared. The leading term on the bottom should be 5x right here. Now, we look at this one, we see that the highest degree on the top is going to be 2. The highest degree on the bottom should be 1 right here. So, the degree on the top greater than the degree on the bottom, 1 unit. Alright, so in this situation, we have slant asymptote. Alright. So this is slant asymptote. Alright, we don't have the horizontal asymptote. Now, in order to find the slant asymptote, we need to do long division. Alright, so go ahead do long division. We have 2s squared minus 4 divided by 5s plus 9. In order to do long division, you need to rearrange this one from highest degree to lowest degree. So this is power 2. We don't have power 1. So we need to add 0, s, and minus 4 right here. Alright, now 2 divided by 5 is going to be 2 over 5. S squared divided by s is going to be s. Now we need to multiply this one back. It's going to be 2s squared. 2 over 5s times 9 is going to be 18 over 5s. Alright, now we need to change the sign. So it could be negative right here, and then we're going to add them up. Alright, so this guy cancel out. This guy turns out to be negative 18 over 5s. Now we need to bring negative 4 down. We're going to take negative 18 over 5s divided by 5. So it turns out to be negative 18 over 25. Alright, we're going to multiply this guy back. So it's going to be negative 18. Negative 18 over 25 times 9. It's going to be negative 162 over 25. Alright, now we need to change the sign of this one, and then we're going to add them up. Alright, so this guy cancel out. Alright, this guy add this guy, it turns out to be 62 over 25. Alright, since degree of this one less than degree of this one, so we need to stop right here, and the remainder is 62 over 25. Our slant asymptote should be this guy right here. Alright, so the slant asymptote should be y equal to 2 over 5s minus 18 over 25. Now, if you want to review the long division or synthetic division, please check out the video in the description. Alright, so let's move on to the next one. Alright, so we have the leading terms on the top should be 4s. The leading terms on the bottom should be 8s. Since this guy and this guy have the same degree 1. Alright, so we have the horizontal asymptote is going to be 4 over 8. It's going to be 1/2. Now, next one. The leading terms on the top should be 3. The leading terms on the bottom should be s squared. And you see nothing right here, which means s power 0. Alright, so we see that the power on the top is going to be 0. The power on the bottom is going to be 2, which is the top less than the bottom. Alright, so we have the horizontal asymptotes y equal to 0. Now, question F. The degree on the top should be 0. Degree on the bottom should be 1. So because the degree of the leading terms on the top is 1 unit less than the degree of the leading term on the bottom. So we have the horizontal asymptote, which is y equal to 0. Alright, we need to find the limit notation for this guy right here. Now left, which means, so let's the function f of s right here. Limit of the function f of s when s approaches negative infinity. Alright, so negative infinity right here. So when s approaches negative infinity, y value approaches to 2 right here. Right, the horizontal asymptote right here. So equal to 2. Now limit of the function f of s when s approaches positive infinity equal to, this is to be 2. Now this one, s approaches positive infinity, so it's go this way. The function is going to be like this. So y value approaches 2. For this one, limit of the function, I call this is g of s. limit of the function g of s when s approaches negative infinitive. So when s approaches negative infinitive, which is this guy right here, y value approaches negative 1 right here, which is the horizontal asymptote right here. So it could be negative 1. Limit of the function g of s when s approaches positive infinitive. So positive infinitive is go this one right here. And the y value approaches negative 1, right? So the answer is negative 1. Now the slant asymptote is the degrees of the leading terms on the numerator greater than the degrees of the leading terms on the denominators 1 unit. And then we have a slant asymptote, which we need to do long division to find the slant asymptote. Alright, so let's look at example number 3 right here. Which of the following rational function has a slant asymptote parallel to the line y equal 1 over 2s? The leading term is going to be s squared. The leading terms right here it could be 2s squared. They have the same degree. So these guys have the horizontal asymptote. Alright, so this guy is not the answer, because we need a slant asymptote. Now, degree on the top right here, 2. Degree on the bottom is going to be 3 right here. Degree on the top less than degree on the bottom. This guy has horizontal asymptote. Alright, so this is not the answer. Degree on the top right here is going to be 2. Degree on the bottom is going to be 1. Alright, so this is actually have the slant asymptote because this guy greater than this guy 1 unit. Alright, so the answer must be this guy. And the last one, degree on the top is going to be 4. Degree on the bottom is going to be 2. The degree on the top is 2 units greater than the degree on the bottom. So these guys does not have the slant asymptote. So the answer must be 3 right here. So which is C. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.